Alright, we're still talking about compound inequalities. We've already discussed the idea of the conjunction. Now let's look at the disjunction. Disjunction is defined as a disconnection. We're going to break the chain. They're no longer going to be connected together. In terms of compound inequality, a disjunction is a pair of disconnected inequalities. A disjunction is a pair of inequalities separated by the word or, as in one inequality will work or the other one will, but not both. Think of when you're driving, you come to a T intersection, the road ends. You see this sign. It means you have a choice to go left or you can go right. There's no other option. You can't go straight. You can't pick any other option. So when solving disjunctions, once again, they stay separate. They cannot be connected. So we have 7x minus 7 is less than negative 7. Or, the same expression, 7x minus 7 is greater than 12. You solve each inequality separately, they'll follow the same process. So let's solve them side by side and see how it works. We're going to use the standard equation solving process. When I see a minus 7, you do the opposite. Change that subtraction to an addition, and you add to both sides. We're going to do the same thing to the inequality on the right. Change that subtraction to an addition, add to both sides. Let's rewrite it. Your negative 7s and positive 7s are going to cancel to give you zeros. Over here on the right, 21 plus 7 is going to give you 28. So rewrite each inequality. The inequality arrows do not change. I see that I'm multiplying by 7. So again, the opposite of multiplying is division. I will divide both sides by 7. I'll repeat the same process on the opposite inequality. And rewrite. On the left, 0 divided by 7 is 0. On the right, 28 divided by 7 is 4. So my inequalities are solved. That is my solution. X is less than 0. All numbers less than 0. Or X is all numbers greater than 4. So when we graph it, we still want to take a look at our number line. And we'll graph each inequality separately, but because they are indeed compound inequalities, that we put on the same number line. So first one, X is less than 0. My number of interest is 0. It will be an open dot because there's no equal sign. X is less than. It's smaller than 0, which goes to the left because those are negatives. Repeat the same process for the inequality on the right. Number of interest is 4. So at 4, once again, open dot. X is bigger than 4. Bigger goes to the right. And this is your graph of your disjunction. They're not connected as a conjunction is. They go opposite. You go left or you go right. One or the other. Now, let's take a look at the interval notation. I have two inequalities to write a set notation for. So I'm going to write the set notation for one on the left first. The one on the left, let me put it in the top right corner here. It goes as far down as negative infinity and only as high up as 0. And since I have an open dot as a parentheses, negative infinity, remember, is not an actual number. It's a concept. It's not a number you can plug in, so you can't actually use it. Or my second inequality. My smallest number is 4. I go from 4 all the way up to, that arrow goes on forever, positive infinity. Open dots, so they are going to be parentheses. Two pieces of interval notation. You have two individual graphs. They're just on the same number line. And this is how you work with a disjunction.